13.
Yes, sir.
Okay. 14. 15. 16.
Present, sir.
Okay. 17. 18. 19.
Present, sir.
Right. 20.
Present, sir.
Okay. 21. 22. 23. 24. 25. 26. 27. 28. 29. 30. 31.
Present, sir.
Right. 32. 33. 34. 35. 36. Pratmesh. Joslino. Joslino. Soham. Atia. Anybody else join?
Sir, 21.
Okay. Anybody else? Anybody else? Right. The last class we discussed an example on the cascaded amplifier, right? Today let us solve two more numericals. I hope everybody are able to see the screen. Screen is visible.
Yes, sir.
Okay, note down this example. Calculate the DC bias voltages and currents in the circuit of below figure. Calculate the DC bias voltages and currents in the circuit of below figure. Note down the circuit. This is the basic Darlington bias circuit. Darlington circuit. RB is 3.3 mega ohm. VCC is plus 18 volts. Darlington beta that is current gain of Darlington pair is 8000. VBE is 1.6 volts. RE is 390 ohm. RE emit resistance is 390 ohm. The connection is from emitter of first transistor is connected to base of second transistor. Collector of both transistors are shorted. Then emitter of second transistor is connected through resistance RE to ground. The base of first transistor is connected to VCC through resistance RB, through the base resistance RB. This is the Darlington bias circuit, Darlington connection. Quickly note down the circuit.
Sir,
Yes. Anybody wants to get in? Any questions?
sir, Suraya Banu is trying to join, sir, but it's not. We are
Allowing
not
1 minute.
letting her in.
No, I have already shared the screen. I will just see 1 minute.
She's trying since 5 minutes, sir. It's not
No, I have allowed
coming.
everyone. I have allowed. Now I'll admit him. RC. Sorry, I have admitted. Okay, fine. Take down this numerical quickly. Is it noted down? Did you all note down the circuit? Did you all note down here? Shall we proceed?
Yes.
Okay. Now what they have asked, read the question. So first understanding the question is very important, right? First you have to read the question, understand, see what is given and what is being asked. Okay. Don't simply start writing the solution or start writing the answers. Okay. In the test also the question number 4C, right? I have asked the voltage divider bias RE model, but some of you have written the hybrid model there, right? So like that you have to see what is asked and what is being given, read the question, understand, and then write the answers. Okay. Calculate the DC bias voltages and currents in the circuit of below figure. Now this is a circuit which is given. They have asked to calculate the DC voltages, DC bias voltages and the currents. Now we have already done the DC analysis of this Darlington bias circuit. We already done the DC analysis of this Darlington bias circuit and we have got the equations. We already derived those equations, right? The analysis is like this. The base current is given by the equation IB is equal to VCC minus VBE divided by RB plus beta D RE. Note down the formula. Base current is given by IB is equal to VCC minus VBE divided by RB plus beta D RE. Now VCC is given. It is 18 volts. VCC is 18 volts. VBE also they have given 1.6 volts. VB this voltage of the Darlington connection. Then that divided by RB base resistance is given 3.3 mega ohm plus beta value is given beta D 8000 into RE 390 ohms into 390 ohm. Okay, RE is 390 ohm. This comes out to 2.55 microampere. 2.55 microampere. Just check your answers. IV value will be how much? Just see. VCC minus VB divided by RB plus beta D RE. Check how much you are getting. What is the answer, students? How much you all are getting? Yes, how much you are getting? VCC minus VBE divided by RB plus beta D RE. What is the answer? How much you are getting? Yes, please. Anybody getting the answer? Ankita, what is the answer you are getting? Janvi?
Doing, sir.
Okay, do the calculation. VCC minus VBE divided by RB plus beta D RE. Do the calculation. Be a little bit fast. Tejas, how much you're getting? Tejas? Mohammed, Mohammed, what is the answer you are getting? Kirti, Kirti, what is the answer? Yes, please. Have you noted down the formula? Ramesh, Ratan, Rutvik, Rutvik, how much you are getting? Rutvik, Gune, Sania, Sania, how much you are getting? Sania, are you getting 2.55 microampere? Yes. Are you getting 2.55 microampere? Ankita, Ankita,
Yes, sir.
you are getting 2.55 microampere. Okay, fine. Next calculate the emitter current. Emitter current formula is 1 plus beta into IB, but 1 plus beta is approximately equal to beta. Therefore, IE will be simply equal to beta D into IB. Now here, beta will be beta D because it is for the Darlington connection. Two transistors connected in Darlington connection. Okay. Therefore, it will be IE is equal to beta D into IB. Beta D is given 8,000 into IB. IB is whatever you have calculated just now, 2.55 microampere. Find out the answer. I is equal to beta D into IB. Beta D is 8,000 multiplied by 2.55 microampere. What is the answer? 8,000 into 2.55 microampere. Rutvik, Rutvik, how much you are getting? Sania, Sania, Tejas, what is the answer you are getting? It's a multiplication of 8,000 into 2.55 microampere. How much you are getting? Ramesh, Prajwal Gowda, Mohammed, Mohammed, Ankita, Ankita, how much you are getting?
Sir, solve.
Yes, how much you are getting, Ankita?
Sir, 2 minutes, I'm solving it.
How much? Ankita, how much is the
Sir,
answer?
I'm calculating it, 2 minutes.
Okay, okay. Take your time. Be a little bit fast. It's just a multiplication of 8,000 into 2.55 microampere.
Sir, 20.48.
Correct. 20.48 milliampere. Okay. Now this IE current, whatever is flowing here, that is approximately equal to IC, collector current. The reason is this base resistance is very large. Base resistance is very large. It is in terms of mega ohm, and hence the current which is flowing through this base resistance is very less. Hence, we can consider that whatever is the collector current flowing, that is equal to the emitter current because base current is negligible. Therefore, we say that the IE current, whatever we have obtained here, that is approximately equal to the collector current IC. Right? Then next, emitter DC voltage. Emitter DC voltage is VE. The formula is VE is equal to IE into RE. Formula for emitter voltage is IE into RE. That is emitter current into emitter resistance. emitter current into emitter resistance. Calculate how much you are getting. IE into RE. IE you have calculated just now, it is 20.48 milliampere into emitter resistance into 390. Into 390. Calculate and see how much you are getting. How much you are getting?
8.059.
8.059. Yes, it is 8.059 or approximately 8.06 volts. Correct. Approximately 8.06 volts. V is equal to IE into RE. IE we have calculated 20.48 milliampere. RE is given 390 ohm. Multiply them, we'll get 8.06 volts. Next, base voltage. Base voltage is VB. VB. Apply the KVL here. So it is VB. We want this voltage between base to ground, right? Base to base terminal to ground. That is VB minus VBE of the Darlington pair minus IERE is equal to 0. VB minus VBE minus IERE is equal to 0, or VB will be equal to VBE plus IERE. Am I right? VB will be equal to VBE plus IERE according to the KVL. Okay, that is what it is written here. VB is equal to VE plus VBE. VE we have calculated just now, it is 8.059 approximately 8.06 volts or 8 volts plus VBE. VBE they have given, it is 1.6 volts. So approximately it comes to 9.6 volts. Okay, 8 volt approximately plus 1.6 volts VBE, that will be equal to 9.6 volts. Fine. Next, so we have calculated the base voltage. Next, coming to the collector voltage. Collector voltage is nothing but the supply voltage, that is plus 18 volts. The reason is again the same thing, because of large value of the base resistance, the current that is flowing through this base resistance is negligible, and hence the voltage across the collector is nothing but the supply voltage. It is nothing but the supply voltage. The voltage drop is also less here, and therefore the voltage drop across the collector is nothing but the supply voltage, that is plus 18 volts here. That is what we are writing is collector voltage is nothing but the supply voltage, that is 18 volts, that is equal to VC. The collector voltage is nothing but the supply voltage. Because of large value of the base resistance, the current that is flowing through base resistance is negligible, and hence the voltage across the collector will be equal to the almost the supply voltage, that is 18 volts. That is collector voltage equal to supply voltage equal to 18 volts, that is VC, collector voltage. Okay, so these are the DC bias voltages and currents in this Darlington connection pair. Okay, Darlington pair connection it is. So in the examination they may give you the figure, and they may ask us to calculate the DC bias voltages and currents for the below figure or for the given circuit. Okay, so they will give you all these values and they will ask you to calculate. Next, let us move on to the next numerical. Take this numerical, students. A given amplifier arrangement has the following voltage gains: AV1 equal to 10, AV2 equal to 20, AV3 equal to 40. What is the overall voltage gain? First part of the question. And also express each gain in dB and determine the total voltage gain in dB. It's an examination problem. In the examination, it has been asked for twice or thrice, right? Examination problem it is. A given amplifier arrangement has the following voltage gains: AV1 equal to 10, AV2 equal to 20, AV3 equal to 40. What is the overall voltage gain? Also express each gain in dB and determine the total voltage gain in dB. Note down this. Note down the example. Note down the statement of the problem. Did you all note down? Note down, students. Shall we
Yes, sir.
the solution? Okay, okay, fine. Now here we know that for the cascaded stages, they are given amplifier arrangement has following voltage gains. That is, first stage has a gain of 10, second stage has a gain of 20, third stage has a gain of 40. What is the overall voltage gain? Right? We know the formula that if the individual gains are given, individual gains of each stages are given, then the total gain is given by the product of the gains of individual stages. That is, total gain is AV1 into AV2 into AV3. That is, the product of gains of individual stages will give the total voltage gain of the entire amplifier, of the whole amplifier. Okay, that is, AV is equal to AV1 is 10, AV2 is 20 into AV3, that is 40. Multiply them, 10 into 20 into 40. See how much you get. 10 into 20 into 40. Just check. 10 into 20 into 40. What is the answer? Ten into 20 is 200. 200 into 40 is how much?
8,000.
8,000. Correct? Yes. It is 8,000. Okay. So 10 into 20 is 200. 200 into 40 is 8,000. This is the total gain of the amplifier. Next, what they're asking is also express each gain in dB. Also express each gain in dB. That is, you have to express these voltage gains. You have to say find out the voltage gain of the given gains in dB. You have to find the gain values in dB and then find the total voltage gain in dB. Now, if you want to find the voltage gain in dB, what is the formula? 20 log the gain to the base 10. Okay. Now, AV1 is 10. 20 log this value to the base 10. That gives the gain in dB. Remember, the formula to find out the gain value in dB is 20 log the given gain value with the base 10. 20 log the given gain value with the base 10, that gives the gain value in decibels in dB. Okay. Now for the first one, they are given gain as 10. 20 log 10 to the base 10. Calculate how much it is. 20 log 10 to the base 10. Take your calculation, all of you. All of you should calculate here. Everybody should calculate. I may ask randomly anyone. 20 log 10 to the base 10 is how much? Logarithm 20 log 10 to the base 10. How much you are getting? What is the answer? 20 log 10 to the base 10.
20, sir.
20. Very good. 20 log 10 to the base 10 is 20. Similarly, for the second one, 20. Gain value is 20. Let us find out. Formula is 20 log the given base value, the given gain value to the base 10. It is 20 log 20 to the base 10. 20 log 20 to the base 10. Calculate how much it is. 20 log 20 to the base 10.
Sir, 26.02.
Very good. Third one, 20 log, what is the gain value they given? Third one, 40. 20 log 40 to the base 10. 20 log 40 to the base 10.
32.04.
Yes. So it is 32.04, approximately 32. Okay. Approximately 32. We have calculated the gain values in decibel of the given gain values. Right. Next, what they are asking is, and determine the total voltage gain in dB. You have to find the total voltage gain in dB. Now, to find the total voltage gain in decibels, we have to add them. We have to add the voltage gains, whatever we have got in decibel, individual voltage gains, that will give us the total voltage gain in decibels. Okay, we have already taken the logarithm of these values. Now, if you want the total voltage gain, we have to add the gain values which are given in decibels. It is 20 plus 26 plus 32. Find out how much it is. 20 plus 26 plus 32. 20 plus 26 is 46. 46 plus 32.
So 78.
78 decibels. Right? Already these values are in decibel. Just we have to add these decibel values so that we get the total voltage gain in decibels. It is 20 plus 26 plus 32. That will be 78 dB. That is total voltage gain in dB will be equal to 78 decibels. 78 dB. Okay. So this is the numerical on the cascaded stages. Right. Next, I hope everybody understood these two examples. Any difficulty here in these two examples? Any difficulty in these two examples?
No, sir.
Fine. Next, we'll move on to a new concept, that is the next part of the third module is the feedback concept. Feedback concept. Now here there are two parts. One is the forward, this part, this is the amplifier portion. A, whatever is written, this is the amplifier portion, amplifier circuit, and one more circuit is there which is called as the feedback circuit. This beta, whatever is written, it is called as the feedback circuit. Feedback circuit. Okay. Now here, this is in the front portion, the forward portion, it is the amplifier, and the one more portion what we are having is the feedback circuit or the feedback portion. The supply signal is applied to this portion which is called as a mixer, right? So positive, negative, whatever is indicated here, it is applied to a part of this feedback amplifier circuit which is called as a mixer circuit. Mixer, as the name itself indicates, that it adds the two input signals. It performs the combination of the applied two input signals. Okay, one is the Vs we are applying, another one is the output of this feedback circuit, that is Vf. Therefore, Vs minus Vf. Vs is plus, Vf is minus, Vs minus Vf, that will be equal to Vi. Now here there are two types. The output of this feedback circuit can be positive. Output of this feedback circuit can be negative. If the output of this feedback circuit is negative, here the polarity will be minus. If the output of this feedback circuit is positive, then the polarity here will be plus. Polarity here will be plus. Okay. Now here let us consider for the amplifier, the output of this feedback circuit is always negative. Remember, for the amplifier circuits, the output of the feedback portion, that is always negative. Therefore, the mixer will perform the combination of Vs minus Vf. That is, supply signal is Vs, feedback signal is Vf. Vs minus Vf will be equal to Vi. Vi is Vs minus Vf. Vs minus Vf. Okay. Now, there are certain circuits called as oscillator circuits. For the oscillator circuits, the feedback from this, the output from this feedback portion will be plus. Right? Then it is going to perform Vs plus Vf. Vs plus Vf. That is addition of Vs and Vf. But here it is Vs minus Vf. That is nothing but equal to Vi. Then the output, whatever we are getting from the amplifier, the portion of this output signal is applied as input to the feedback circuit. This is beta is the feedback circuit. Part of the output signal, whatever we are getting from this amplifier, that is applied as input to this feedback circuit. Okay, and the output that we are getting from this feedback circuit is portion of the output signal, is some portion, a portion of the output signal that is applied as, or that is the output that we are getting from the feedback circuit. Okay. So this is how this is a feedback circuit. It consists of the forward portion, that is the amplifier, and in the feedback portion we have the feedback path or the feedback circuit, and the combination of these two, that is the amplifier and the feedback circuit, that gives us what is called as the feedback amplifier circuit. So such circuits are called as feedback amplifiers. The feedback amplifier consists of the amplifier, normal amplifier, and in the feedback path there is a circuit, right, which provides some portion of the output of the amplifier as its output. The output of the feedback portion will be some portion of the output provided by the amplifier circuit. Okay. So this is the block diagram of the feedback amplifier. In examination, if they ask, explain the concept of feedback amplifiers or explain the feedback concept, then you have to draw this diagram and then explain what is a mixer circuit, what is the function of amplifier, what is the function of the feedback path, right? And how the output is applied to the feedback circuit, output of the amplifier, then what output we are getting from the feedback path. Okay. Then if feedback path is negative, then the amplifier input Vi will be Vs minus Vf. If the feedback output is positive, then we get Vi equal to Vs plus Vf. If it is negative output from the feedback path, then it is amplifiers circuits. Then if it is oscillator circuit, then the output from this feedback path will be plus. Okay, that is plus. It is negative means both are out of phase with each other. Vs and Vf are out of phase with each other. If Vf is plus, then Vs and Vf are in phase with each other. Okay, that is the meaning of plus and minus here, right? Feedback connection is as shown. The input signal Vs is applied to the mixer circuit. Mixer circuit combines the input signal Vs with the feedback signal Vf. The difference between these two, that is Vs minus Vf, is applied as input to the amplifier. Vs minus Vf is applied as input to the amplifier. The portion of output of the amplifier V0 is connected to the feedback network. So the portion of this output V0 that is applied as input to the feedback network. Feedback network provides a reduced portion of the output as feedback signal to the input mixer network. This feedback network provides reduced portion, okay, reduced portion of the output of the amplifier as input to the mixer circuit. Okay, that is what it is. If the feedback signal is of opposite polarity, as shown in the figure, that is minus, then the negative feedback results. Okay, if this output of the feedback network is negative, then it is called as negative feedback amplifiers. If the output of the feedback network is positive, then they are called as positive feedback amplifiers. Okay, negative feedback amplifiers and the positive feedback amplifiers. Negative feedback results in, now this negative feedback, whatever the negative feedback is applied from the feedback network, from the feedback circuit, which may consist of resistors, capacitors, right? Feedback circuit. Then this output of the feedback network, okay, that is resulting in Vs minus Vf. So as it is a subtraction operation, then naturally the Vi will become less. Vi will become less. When Vi becomes less, the V0 will become less. Output voltage V0 becomes less. The gain becomes less. The gain V0 by Vi becomes less. That is, the negative feedback results in a reduced overall voltage gain. The gain of the circuit will be decreased because of the negative feedback. Remember, the negative feedback results in decrease in the overall voltage gain. Then what are the advantages of this negative feedback? Even though there is decrease in the overall voltage gain, it provides high input impedance. We'll see how it is providing high input impedance in the later part of the subject, later part of the topic here. That is, it provides high input impedance, low output impedance, right? Then less noise will be reduced because it is performing Vs minus Vf, the subtraction operation. The noise will decrease and noise will be reduced, right? Then the gain stability is good. Okay, it provides good gain stability because the gain is decreasing here. The gain is stable. It provides a stable gain, right, which is not fluctuating. Stable gain. Frequency response is good. It provides good frequency response, right? Frequency response means it's a graph of the gain versus frequency. As a gain is stable, therefore the frequency response will also be good. What is the frequency response? It is a graph of the gain of the circuit versus frequency. It is called as frequency response. High input impedance, better stabilized voltage gain, improved frequency response, low output impedance, reduced noise, and linear operation. Linear operation, that is, there is linearity between the output and the input. As the input increases, the output also increases. As the input decreases, the output also decreases. These are the advantages of the negative feedback amplifiers. Okay, negative feedback circuits, right? High input impedance, stabilized voltage gain, improved frequency response, low output impedance, decreased noise, and linear operation. Okay. Now there are four types of feedback connection types, right? I'll just mention them here. There are four types of feedback connection. This depends on connecting how the feedback signal is connected. There are four basic ways of connecting the feedback signal. The voltage and current can be fed back to the input either in series or in parallel. Now, whatever this voltage or current we are getting from this feedback network, that we can connect to the input in series or in parallel with the input. In series with the input or in parallel with the input. Okay. So depending on this, there are four types of feedback connections or feedback topologies or feedback connection types. One is voltage series feedback, second voltage shunt feedback, third current series feedback, and fourth one is current shunt feedback. Voltage series feedback circuits, voltage shunt feedback, current series feedback circuits, and current shunt feedback circuits. These are the four basic feedback connection types, okay, or the feedback topologies, feedback circuits: voltage series, voltage shunt, current series, and current shunt feedback circuits. Okay. In the next class, we'll discuss in detail these different feedback circuits: voltage series feedback, what is meant by voltage series feedback, what is voltage shunt feedback, what is current series feedback circuit, and what is current shunt feedback circuit, and how is the connection in the block diagram of these different feedback circuits. Okay, that we will take up in the next class, right? Hope you all understood the today's topic, students. Any difficulty here? Any difficulty here in today's topics? In today's topic, we discussed the numerical on the Darlington connection, right? And one numerical on the cascaded amplifier. Then we have started with the new topic, that is feedback concept. Feedback concept. I explained what is meant by feedback, what it consists of in the block diagram. Then feedback amplifier, feedback concept, the concept of feedback circuits, feedback amplifiers, right? Then what are the advantages of negative feedback circuits? Then we have mentioned the four basic types of feedback connections: voltage series, voltage shunt, current series, and current shunt feedback connection types. Okay. Any difficulty here, students? Ankita, any difficulty? Ankita?
No, sir, no difficulty.
Okay. Chandrasekhar?
Clear, sir. All clear, sir.
Fine. Mahadev? Harshgowda? Mohammed? Mohammed? Kirti? Kirti? Ramesh? Ramesh? Rutvik? Rutvik?
Yes, sir.
Any difficulty, Rutvik?
No, sir.
Fine. Sagar? Sai Prakash?
Yes, sir.
Sai Prakash? Any problem in understanding Sai Prakash?
No, sir.
Good. Samir Ahmed? Samir Ahmed? Sania? Sania?
Yes, sir.
Anything not understood, Sania?
No, sir. Understood.
Okay. Tejas? Tejas? Tejas Aksar? Okay. Then we'll continue with the next this feedback connection types in the next class, that we'll take up in detail in the next class. Thank you.